Okay, welcome to part two of the lesson. So, what we are going to do is we are going to identify the different layers within the Earth and how we know about them. So, in assignments, there is this sheet. What you are going to do is, based on the information from the video you just watched and what I'm about to give you now, you can print off and fill in this sheet. This section, you are probably going to need to watch the second video and possibly even do some of your own research before you understand that. So you can print this off and stick it in your book. However, if you do, you'll need to add some of these labels once I've talked you through them. Or you can simply copy this into your book with the labels and then add a few of the bits like very thin descriptions, all of that. Okay, so firstly, the Earth is divided up into sections. So if we were to cut through the Earth like this, the outermost layer, the part that we're familiar with, is solid rock, and that's called the crust. Okay, now that's between 6 and 90 kilometers thick. Okay, and a couple of things about this. As I said, it's made on solid rock, and it's broken up into plates that float on the mantle. So it's not one solid layer. Okay, it's not like a shell, or if it is, it's like a shell with lots of cracks in it, which sort of float around on top of the next layer, which is called the mantle. Okay, now we've only drilled about 20 kilometers down into the crust. So then that raises the question, well, how do we know about all these other layers? Well, it's actually very, very clever, and we're going to discuss that in the next lesson. Right, now the layer underneath that is the thickest layer. This is about 4,000 kilometers thick, okay? That's called the mantle, and it's a hot, and it flows like a thick liquid, so it's sort of nearly solid, but kind of almost nearly liquid as well. It's basically melted rock, okay? So semi-melted rock, and it flows really slowly around, okay, basically up and then down, and then it gets heated again and up and then down like that. And yeah, that's got the consistency of like a really thick jelly. It's not really properly melted. However, as you go deeper and deeper and deeper, it gets hotter and hotter and hotter. And so you reach this layer, the outer core. Now, the outer core, it has melted, and that is properly liquid. Okay. And then the inner core is a bit strange. It's solid. Now you might think, well, hang on a minute, how can that happen? Because as things get hotter and hotter, surely they would melt. Okay, so this would be liquid too, but it's not, it's solid. Now the reason for that is because of this. Okay, imagine how much rock is pushing down, because gravity pulls everything towards the center of the Earth, like this. So if I just draw some arrows showing you this, basically what happens is the weight of rock on top, so millions of tons of rock all pushing down towards the center of the Earth, that creates a huge weight, a huge pressure, pushing, pushing, pushing. So it's like getting a snowball, okay? If you think in winter, you get a snowball and it's made from that loose, powdery snow. But what happens to it if you squeeze it? Well, the loose, powdery snow is, almost a bit like a liquid. It's easy to shape. But if you get that loose, powdery snow and squeeze it as hard as you can in your hand, if you squeeze it really hard, you'll compress it into ice, essentially make an ice ball. Solid. Well, basically the same thing is happening here. The stuff at the inner core gets squeezed so much, it gets squeezed out of a liquid and back into a solid. So even though it's hotter, it doesn't melt because it's being squeezed and squeezed and squeezed into a solid. Okay, so what you need to do now is you can draw this into your book, or you can draw it directly onto the sheet, but you need to add all of these labels. Okay, so in a moment you're going to pause the video and do that, and then using your key, color the boxes to show which parts of the structure they are referring to. Okay, so for example, which part is a liquid, which part is very thin, which has a radius of about 3,500 kilometers. I said 4, but you get the idea. Okay, so have a think about that. The video should also help you. One other little footnote, the inner core because the materials are heaviest and densest, they've essentially sunk to the bottom. Iron and nickel are really dense, so they form the inner core and also part of the outer core as well. Now, those of you remembering from year 7 will remember that iron and nickel are magnetic materials. Now, that's really interesting because as this liquid iron and nickel, because they've melted in the outer core, swirl around, they create a magnetic field. And that magnetic field extends all the way up through the mantle, all through the crust, and actually out of Earth's atmosphere and into space. And that's got nothing to do with gravity, it's a magnetic field. And you might think, well, that's interesting. It's more than interesting, it's essential for life. Without it, we wouldn't be here because the Earth's magnetic field deflects harmful radiation from the sun around the Earth, and without it, there would be no life on Earth. So the inner core, we'll never see it. But we do know it's made of iron and nickel because it creates a magnetic field that surrounds the Earth and protects us from the sun's harmful radiation. Okay, so once again, can you please pause the video and either do the sheet here or straight into your books? You can have this. Okay, off you go, please. Okay, welcome back. So, as I said before, the Earth's surface is not one solid layer. It's broken into pieces called tectonic plates, and the plates sit on top of the mantle and move with convection current in the molten rock. Now, because these plates move, something rather strange happens. So here's a map. This shows where all the plates are, and as you can see, they're like broken pieces of rock floating on top. Now, there are 3 kinds of plate boundaries. So, for example, if we go to this one here, this is the Atlantic plate. These 2 are actually, sorry, I just realized I got that around the wrong way. Just quickly change that. Right. They are moving away from each other like this. So at the plate boundary, oops, they are coming apart like this. All right, I'm going to talk about what the consequences are of that in just a moment. So the first diagram you're going to draw is of something called a constructive boundary. So you'll need to draw something like this and call it a constructive boundary. And I'm just going to explain to you how this happens. So what happens is the 2 plates are moving apart. One's moving in one direction, one's moving in another. And so the magma, which is in the mantle, bubbles up in the gap between them. And as it cools, it creates or constructs new crust, new rock, because it cools into rock. Remember, the mantle is liquid rock, so as it comes up, it bubbles up and it cools down. So we call it constructive boundary because new plate, new rock is being constructed from magma, which bubbles up from underneath the ground. Okay, so pause the video and quickly draw in that diagram with the words constructive boundary and then a couple of sentences just to explain what happens. Off you go, please. Okay, so the next one is a destructive boundary, and that's, for example, happens, whoops, sorry about that. Right, so a destructive boundary is when 2 plates are not going apart, but colliding together. So that's like what's happening at the Indian plate and the Eurasian plate. Okay, so a destructive boundary looks a bit like this. The 2 plates are coming together, and what happens is one gets pushed underneath the other. So you can sort of model this with your hands. If you push your hands flat together like this, if you push and push, eventually one gets pushed down underneath the other. So the reason it's called destructive is because this plate, as it gets pushed deeper and deeper underground, it will melt back into the mantle, and so the rock, the plate, or the crust gets destroyed. Okay, hence the term destructive boundary. Now, a couple other things can happen here. You get lots of volcanoes, but also you can get mountain ranges at this kind of stage because as well as being pushed under, sometimes they push and buckle up. And again, if you just model this with your hands, you can see that if you push against your hands, sometimes they buckle upwards. And that is what gave us the Himalayas. These 2 plates colliding and pushing against each other, buckling the crust upwards, creating huge mountain ranges over millions of years. So once again, can you pause the video, draw in this diagram, and a quick description, a couple of sentences, how we get a destructive plate. Okay, welcome back. So the last kind of plate you need to know about is called a conservative plate, and that's when the two plates slide past each other. So this happens here between the North American plate and the Pacific plate. And as you can see, one plate is going one way, one is going the other. And once again, you can get mountains and volcanoes here, but this is really a big area for earthquakes. Now you can get earthquakes, volcanoes, and mountains at all of these plate boundaries. But what happens is, as the two plates slide past each other, what will happen is they'll lock, but they're still moving deep down in the mantle. So they're locked to the crust, but what happens is the plates will keep moving deep beneath the earth near the mantle. And eventually, it kind of snaps and is forced forward. And that is what gives rise to earthquakes. So conservative boundary, there's no destruction or construction of new crust. Essentially, it's just the crusts sliding past each other, but it's a really big earthquake zone. So once again, can you pause the video, draw that in with a quick description of what's happening? Okay, so well done, Year 8. So what we're going to do today, or what you should have by today, is your test answers uploaded. You should also have a diagram of the interior of the Earth, all labelled up, either in your book or on this sheet, with these labels added. And you should have your 3 descriptions of your plate boundaries. Now, to help you with this, there is a second video in assignments. You can use that to make sure you understand these 3 plate boundaries. So once again, final thing, pause the video and have a look at the YouTube video, and then make sure you've got your all 3 items done. Okay, as always, I'll be online to help if you need it.